Okay, I'd like to continue with some of the problems that we did in class today about changing the word problems into a sinusoidal function. So let's look at example number 3 because we did 1 and 2 in class. A Ferris wheel is 46 feet in diameter. So let's draw that. Here's my Ferris wheel. My diameter is 46 feet. Okay, it makes one revolution every 120 seconds. So from here to here is 120 seconds. You climb up a height of 8 feet steps, 8 feet of stairs to get to the wheel at its lowest point. So from here to the floor is 8 feet. Okay, which makes sense because if you're on a Ferris wheel, you know, your legs are hanging down, you don't want it to hit the ground. All right, they want you to model the height after one revolution. Okay, so let's see what we could talk about this. What is the highest point this graph reaches? We know you have 8 feet off the ground and then another 46 feet in diameter. So 46 plus 8 is 54 feet. So at maximum height, you're at 54 feet. At the minimum height, you're at 8 feet. And that's when you get on. So the lowest you're at 8 and the highest you reach is 54. We need to find the middle. Remember, the middle is your midline. To find the midline, you take your max height, you add it to your minimum height, and then you divide it by 2. So this is going to be 62 over 2, which is 31. So remember when we write this function, okay, it's y equals a. It's either going to be a sine or a cosine. It's going to be b, and then it's x plus or minus c if we shift it horizontally, plus or minus d if we shift it vertically. It's telling me that the middle is at 31. So my d equals 31. Okay, now my height from my midline to the highest point, we're just going to take 54 is the highest, subtract the 31, and we know that the A, your amplitude, is 23. Now according to this problem, you complete one rotation 120 seconds. So that means that your period is 120 seconds. Well, to find your B, because we're not having a phase shift, okay, because we're going to start the graph here, this is where you're going to get on it, okay, we're not going to have a C, we have the A, we have the D. To find the B, we're going to take 2 pi and divide it by the period, which is 120, which is pi over 60 for your B. All right, if I think about this function, I'm starting here at the lowest point. As I go around, now I start to increase, and then I get to the highest point. Then I come back down to get off the ride 120 seconds later. So what kind of function is that? That's going to be a negative or an inverted cosine graph. So y equals negative 23 cosine, my b is pi over 60 x, and my d is 31. Now let's say for argument's sake, I wanted you to write this as a sine graph. Well, remember what we said with sine graph. Sine graph just shifts over 1/4 of the period. And in fact, it would be a sine graph if it started here and continued like this. Okay, so if I want to shift it over 1/4 of the period, okay, the period is 120. 1/4 of the period is 30. So it would be y equals, now if I start here as a sine graph, it's not inverted. It's a positive sine graph. So that's 23 sine. We're still going to have that same b of pi over 60, but now we're going to move that graph to the right, so it's minus, and we're going to start off at the 30-second mark, which honestly I don't know how you're going to get on this Ferris wheel, because that means you're jumping on the Ferris wheel here. Again, there's going to be a reference to the notebook where he jumps onto the Ferris wheel, plus 31. Okay, so those are the two equations that would mirror that situation, question number 3. On the paper that I uploaded in Teams, you have a bunch of other ones. I am going to work those out and then post the answers. I hope this video was helpful.